Good day. So on today's lesson, we are going to go through the divergence of a vector field. So when you talk about the divergence of a vector field, the divergence of a vector field is the extent to which the vector field behaves like a source at a given point. So let's illustrate. So maybe let's say we have this particular ball here. Okay. So when we have points moving towards the ball, then we say that this particular ball is acting as a sink. That's the reason why the points are moving towards it. But if the point moves away from this particular ball, then we say that this particular ball is acting as a source. So divergence just helps us to know the extent to which the our vector field. So let's say this is a vector field. This our vector field is behaving as a source or as a sink. So the divergence is scalar. So note that when you find the divergence of a vector field, you always get scalar. And when you consider the vector field given as f of xy equals p of xyzi plus q of xyzj plus r of xyzk, then the divergence is given as div of f, which is equal to del dot f. So this one is the dot product of the del and f, and this will be equal to del p del x plus del q del y plus del r del z. So that's it with the formula for the divergence. So this is what it simply means. If you have R as a vector field given as p I plus r j plus x k, then the divergence of the vector field f, which is given by del dot f, is given as del xp plus del yr, then plus del zs, and it will give you a scalar. So let's just take an example. So from this question, we had our vector field f to be xz I minus y squared j plus 2x squared yk. So realize that to find the divergence of this vector field, we are going to get the grad dot f will be equal to del x of whatever we have here, that's xc. We're going to get del y of minus y square and del z of 2x square y. So when we find the partial derivative with respect to x here, we're going to get just z. With respect to y here, we're going to get minus 2y. And with respect to z here, because we don't have any z component here, we're going to get 0. So that means when you find the divergence of this particular vector field, we're going to get z minus 2y, which is scalar. Because when you are given exact points of z and y, we can find it to get a value. So always when you find the divergence of a vector field, it gives us a scalar. So thank you.